Hello viewers, a good day to you all. Before us we have equations involving indices, and each of these equations is going to lead us to a quadratic equation. So it means we are going to be needing the knowledge of quadratic equation as well as the knowledge of the laws of indices to solve this equation. So we are going to proceed very quickly. So number one, we have 2 raised to the power 2x minus 6, open bracket, 2 raised to the power x plus 8 equals to 0. Now, from one of our ideas of laws of indices, we can rewrite this 2 raised to the power 2x in this format. Actually, 2 raised to the power 2x means, as we have it here, 2 raised to the power 2x is the same thing as 2 raised to the power 2 times x. And if it is 2 raised to the power 2 times x, it's the same thing as 2 raised to the power x times 2, because x times 2 is the same thing as 2 times x, and it's going to lead us to 2x, just as we have it here. Now, if we want to express it in index form according to one of the laws of indices, we are going to have it as 2 raised to the power x and then raised to the power 2. That's 2 raised to the power x times 2, as we have it here, and that's what is going to give us 2 raised to the power 2x. So I'll be rewriting this as 2 raised to the power x before it is now being raised to the power 2, which of course is going to give us 2 raised to the power 2x. Then minus 6, open bracket, 2 raised to the power x, and then plus 8 equals 0. So this is what we have. So we are going to introduce another variable different from x. If you like, you can use m. If you like, you can use n. You can use p. You can use a. You can use y. Any variable of your choice. So I want to use n here. So I say let 2 raised to the power x to be equals to m. This 2 raised to the power x, that is, I want to make it to be equals to m. So if I put m in the place of 2 raised to the power x, so I'm going to have m in bracket as it was, then raised to power 2. Now minus 6, opening bracket, also in place of 2 raised to power x, I'm going to have m, and then plus 8, that's going to be equals to 0. So if I simplify this out, so I will be having m squared minus 6m and then plus 8 equals to 0. So this has led us to what? This quadratic equation that we have here. You see? Applying the laws of indices leading us towards the quadratic equation. Now, we are going to solve this quadratic equation. Any method of your choice is allowed. If you like, you can use factorization method. If you like, you can use the use of quadratic formula. And if it is completing the square method that is good for you, you are good to go. So I'll be using the factorization method. In factorizing, I'll look for two numbers such that if I multiply, they are going to give me positive 8. And if I add them, they are going to give me what? Negative 6. And those two numbers are minus 4 and minus 2. Because minus 4 multiplied by minus 2 equals plus 8, and minus 4 plus minus 2 is going to give me minus 6. So I'm going to be having m squared minus 2m minus 4m and then plus 8 equals 0. What I've done here is just to reproduce this minus 6 in using these two factors. And of course, I so choose these two factors using the method I told you. Now, what are the product of these two factors is going to give me plus 8, but then their sum is going to give me minus 6, because minus 2m minus 4m is minus 6m. Minus 2m times, sorry, minus 2 times minus 4 is going to give me plus 8. So I'm going to rewrite this in this format. That's m squared minus 2m. I'm going to put that in first bracket, then plus, open bracket, minus 4m here, plus 8 equals to 0. So this is what I will be having. Sorry, this is 2m, not x. 2m. So what is common to these two? I'll have m. So that's going to be m open bracket m minus 2, because m times m is m squared. M times negative 2 is negative 2m. And what is common to these two also, of course, is negative 4. So I'll have negative 4m divided by negative 4. I'll be left with only m. Positive sign divided by negative sign is negative. 8 divided by 4 is going to give me 2. And that's going to be equals to 0. So we can see what is inside these two brackets are exactly the same thing. So I'm going to have to choose only one of them. That is m minus 2. Opening another bracket. Outside this bracket is m, and outside this bracket is minus 4. So m minus 2 multiplying m minus 4 equals to 0. And of course, going by our idea of solving quadratic equation, it tells us that when you solve this, it means that m is going to be equals to 2. M is going to be equals to 2, or m is going to be equals to what? Equals to 4. So when m is equals to 2, of course, there's going to be a value for x, because we say let 2 raised to the power x to be equals to m. And when m is equals to 4, there's also going to be another value for what? For x rather. Now m equals to 2, m equals to 4. So we are going to say when m equals to 2, comma. So it means that 2 raised to power x must be equals to 2. That implies that what are you going to raise 2 to give you 2? Of course, that tells you that x is going to be equals to 1, because 2 raised to power x equals to 2 raised to power 1 here. That is equals to 1, making x 1. Now the other one, when m is equals to 4, when m equals 4, that tells us that from this idea also, 2 raised to power x must be equals to 4, and that says 2 raised to power x must be equals to 2 raised to power 2. And of course, you can see that the two bases are exactly the same thing. So what do we need to do? We just need to what? Equate their power. So if 2 raised to power x equals to 2 raised to power 2, that tells us that x in this case is equals to what? 2. So what are the two solutions to this quadratic equation? Sorry, equations involving what? Indices. The two solutions are x equals to 1 or x equals to 2. So either of these two solutions satisfy the condition of the question that has been given to us. So we'll be moving to question number 2 very quickly, following the same step, and you see that they are actually very simple. Now onto the second question. 2 raised to power 2x plus 1 minus 5 open bracket 2 raised to power x plus 2 equals 0. This is slightly different from question number 1, but then the steps are exactly the same. The steps that we're going to take to solve them is going to be exactly the same. So we're going to have to break down, first of all, 2 raised to power 2x plus 1. And we are going to break this down. 2 raised to power 2x plus 1, according to first law of indices, is 2 raised to power 2x multiplied by 2 raised to power 1. And if it is 2 raised to power 2x multiplied by 2 raised to power 1, this is the same thing as 2 open bracket 2 raised to power 2x. Because of course 2 open bracket 2 raised to power 2x means 2 raised to power 1 multiplied by 2 raised to power 2x, just as we have it here. We know that multiplication is commutative. Alright, so we are going to use this, what has been broken down in the question. So we'll be having now 2 open bracket 2 raised to power 2x, as we had it here, minus 5 open brackets 2 raised to power x, and then plus 2. This is equals to 0. So this is what our question has become now. And like we had it before, in the place of 2 raised to power 2x, we'll be having 2 open brackets 2 raised to power x and then raised to power 2. Just as we broke down question number 1, you can say 2 raised to power 2x, 2 raised to power 2x, that's 2 raised to power x and then raised to power 2, and minus 5 open brackets 2 raised to power x and then plus 2. All of these will be equals to 0. Let me separate this from our working so that we don't mix them up. Now, what do we do? As before, we are going to let a variable, to say let 2 raised to power x to be any variable of our choice, either m or as the case may be. So I choose to use m again. So we let 2 raised to power x to be equals to m. If we let 2 raised to power x to be equals to m, wherever we see 2 raised to power x, we'll be putting m. So this becomes 2 open bracket m and then raised to power 2 minus 5 open bracket m in the place of 2 raised to power x and then plus 2. This is going to be equals to 0. So simplifying, we're going to have 2m squared minus 5m plus 2 equals to 0. So what do we do? This has become a quadratic equation and we need to solve this quadratic equation. So I'm still using factorization method, and the leading coefficient here is 2. So I'm going to multiply the leading coefficient by the constant. So 2 multiplied by 2 is going to give me 4, and that's actually positive 4. So what do I do with that 4? I'm going to look for any two numbers such that if I multiply them, they're going to give me positive 4. And if I add those two numbers, they're going to give me negative 5. And the two numbers are negative 4 and negative 1. Because negative 4 multiplied by negative 1 is going to give us positive 4. And negative 4 plus negative 1 is going to give us negative 5. So in essence, I will be having 2m squared minus 4m in the case of negative 4, and then minus m in the case of negative 1, because this m is same thing as 1m, and then it's going to be equals to plus 2 to be equated to 0. So I come on that to come out my bracket, which is 2m squared minus 4m in the first bracket, then plus open bracket minus m plus 2 in the second bracket, and this is going to be equal to 0. So what is common to these two? Of course, that is going to be what? 2m. So I open a bracket, the product of 2m. 2m squared divided by 2m is going to be m minus 4m divided by 2m. I'll be left with only 2. So what is common to these two also? That's going to be negative 1, open brackets, minus m divided by minus 1 is going to give me m, plus divided by minus m will be minus, and then 2 divided by 1 is going to be 2. So this is going to be equals to 0. So what I have inside these two brackets are exactly the same thing, n minus 2, m minus 2. So I have to choose only one of them. So I have m minus 2 in the first bracket, and then open another bracket. Outside here, I'm going to have 2m, and then here I have minus 1. That's going to be equals to 0. Now, this is going towards the end of the quadratic solution of quadratic equation. And when we have number a multiplying number b according to the rule of quadratic equation, number a multiplied by b equals to 0. It means that either a equals to 0 or b equals to 0, or even both a and b are equals to 0. So what does that tell us? I didn't do this in the first question, but it says that either m minus 2 equals to what? 0, or 2m minus 1 equals to 0. So if m minus 2 equals to 0, what does that tell us? It means that m will be equals to what? Positive 2, because of course if negative 2 cross to the other side of the equal sign, because positive 2. And the second solution says that m is going to be 1 over 2, because if minus 1 cross to the other side, it becomes plus 1, and then we're going to divide both sides by 2, so that m can stand alone. That becomes m over 2, m equals 1 over 2. And according to one of the laws of indices, when we have a fraction like this, 1 over 2, it can be rewritten as 2 raised to power negative 1. So m is either 2 or m is what? 2 raised to power negative 1. So as before, because we say let's 2 raised to power x to be equals to m, we say when m equals to 2, comma, it means that 2 raised to power x must be equals to what? 2. And 2 is the same thing as 2 raised to power 1, because any number raised to power 1 remains itself unchanged. So if 2 raised to power x is equals to 2 raised to power 1, of course, what does that tell us? It tells us that it says that x will be equals to 1. So that's for the first solution. And for the second solution here, as we have it, let me transfer that to this place. When m is equals to 2 raised to power negative 1, it means that when m equals to 2 raised to power negative 1, it tells us that 2 raised to power x also is going to be equals to 2 raised to power negative 1. And that implies that x is going to be equals to what? Minus 1. So in conclusion, therefore, x is equals to, for the first solution, x is equals to 1, or the second solution, x is equals to what? Minus 1. So these two solutions are the values of x that satisfy this particular question. If you put question 3, 7 raised to power 2x, 7 raised to power 2x is 7 raised to power x, and then raised to power 2. Take note of that. Then 2 multiplied by 7 raised to power x. 2 multiplied by 7 raised to power x. It's just same as 2, open bracket, 7 raised to power x. These are all that we need for our substitution. So in the place of 7 raised to power 2x, what will I be having? I'll be having 7 raised to power x, and then raised to power 2, minus 2, open bracket, 7 raised to power x, and then plus 1 equals 0. So that's the first step. The next thing now is to introduce our variable. This time around, say let 7 raised to power x. So let me change the variable this time around. Let 7 raised to power x to be equals to y. I choose to use y. If you like, you can use a, you can use b. So if 7 raised to power x equals to y, so I'll be having what? Y being raised to power 2, and then minus 2 multiplied by 7 raised to power x, so that's going to be what? 2 multiplied by y, which is 2y. And of course, it's going to be equal plus 1 equals to 0. So, as before, what two numbers will I multiply to give me positive 1? If I add them, they will give me what? Negative 2. So I'll be having y squared minus y plus 1 equals to 0. The coefficient of y here is 1. Sorry, negative 1. The coefficient of y is negative 1. Negative 1 multiplied by negative 1 will give me positive 1. And negative 1 plus negative 1 will give me what? Negative 2. That's how I have minus y being same as what? Minus 2y. So what will I be having this time around? I'll be opening my brackets to group them. Y squared minus y plus negative y plus 1 equals 0. And what is common to both? Y. Y squared divided by y is y. Y divided by y is 1. Sorry, what is common to these two also? Negative 1. It's going to be y minus 1 when I factorize. So what is common to these two? Sorry, these two are exactly the same thing. So I have y minus 1, open bracket. What I have here is also what? Y. What I have here is what? Minus 1 equals to 0. And of course, you can see that even these two brackets are is what? They are exactly the same thing. So if they are exactly the same thing, you can just pick only one of them as solve. So that tells us that y minus 1 equals to 0, representing both of them. If y minus 1 equals to 0, it tells us that what? Y equals to what? 1. And you are going to put what? Twice. Because if you solve this separately, you're going to get y equals to 1. If you solve this separately, you're going to get y equals to 1. So what does it tell us? Repeated solution. So that's why we just summarize by saying y equals to 1 twice. So if y equals to 1 twice, what will our x be? And when y equals to 1, it means that 7 raised to power x is going to be equals to what? Equals to 1. And of course, how can we bring this to this format? If 7 raised to power x is equals to 1, what do you know about the law of indices? When you raise any number to power 0, it's going to be equals to what? 1. And of course, 7 is not an exception. So if you have 7 raised to power x, you can bring this other one to this format also to have what? 7 raised to power what? 0. To tell you that the two bases are exactly the same thing, because 7 raised to power 0 is going to give you what? 1. So if 7 raised to power x equals 7 raised to power 0, you sure know that x is going to be equals to what? 0. As usual, question number 4, not difficult. All you need to do is pay attention. So let's move quickly. 3 to power 2x is 3 to power x and then to power 2. It's just like we are repeating the same thing over and over again. Here is what we may have a little or slightly different concept. So we are going to have 4 open brackets 3 raised to power x plus 1. By that idea, that is 4 open brackets 3 raised to power x multiplied by 3 raised to power 1. So if we pull out 3 raised to power 1 outside, we'll be having 4 multiplied by 3, then open bracket 3 raised to power x. Because of course, 3 raised to power 1 is the same thing as 3. And 3 times this same thing as 3 open bracket 3 raised to power x. And not forgetting that 4 was outside before now. So that's going to be 4 multiplied by 3. So eventually what are we having? 12 open bracket 3 raised to power x. And every other thing is just as the same as before. So in the place of 3 raised to power 2x, what are we having? 3 raised to power x and then raised to power 2 minus. So I haven't broken this one down. So what are we going to be having? We'll be having 12 open bracket 3 raised to power x and then plus 27 equals to 0 when that one is well spelled out. So what we'll be having, so we'll say let 3 raised to power x to be equals to k this time around. That's color only for you. Alright, so if 3 raised to power x is equals to k, so that will be having, I'll be having what? K squared minus 12k plus 27 equals 0. So what are the two numbers that will be having in this case? Because -3, -9. -3 times -9, positive 27. -3 plus -9 will give me -12. So I'll be having, when I factorize, if you follow my steps for factorization, what I'll be having is k minus 3 in one bracket, and then k minus 9 in the second bracket. That's going to be equals to 0. Please follow the steps I took in question 1, question 2, and question 3, and how to factorize. You see that this is what is going to give to you. So if k minus 3 multiplying k minus 9 is equals to 0, that implies that the first k will be equals to 3, the second k will be equals to what? 9. So when k equals 3, what are we going to be having? 3 raised to power x will be equals to 3. And this 3 is the same as 3 raised to power 1. That tells us that what? X equals to what? 1. Like that. Or, for the second one, when k equals to 9, it says that 3 raised to power x, according to what we have here, will be equals to 9. And 3 raised to power x, 9 is one of the families of 3. And same thing as 3 raised to power 2. What does that imply? It means that x equals to what? 2 when you equate the what? The two powers. So therefore, x equals to 1 or x equals to what? 2 are the values of x, or are the solutions that satisfy this particular equation. So I give to you solutions to equations involving indices.